Okay. Hello, everyone, those who are here for the Zoom meeting and those who are watching on Facebook in the live stream or later. We are super happy to see you. This meetup is part of the 3D concrete competition, but not an exclusive part. So we are talking about how to prepare your files for 3D printing. And in that regard, some of the methods are universal. I will start with the participants who are here. And those of you who are ready to speak or tell a few words about yourselves, you can switch on your camera. And that way we will know that you are ready to say some words. What you need to say is not much. We also don't have that much time, but it's basically your name, from where you are, maybe the field you work in, and what have you done interesting with 3D printing so far. Yeah, that's basically it. I will show. I'm Matis, I'm an architect, and for me, the 3D printing, and I'm from Riga, he helped to start a company that 3D prints casts for hands with 3D printer. And one of the challenges that we faced was that material always shrinks when it dries. So you had to find these coefficients, I don't know the name in English, factors, how to scale it. So when it dries, it doesn't press the joints of the human hand. And that part was extremely challenging at first. And it varied by the size because it's kind of algorithmic. And then after like 100 examples, we kind of found the ratio, but also sometimes, given that these casts were super long, it kind of warped, and a lot of challenges there were because the precision is not that sometimes. But it was great. It's fine. It was fun. That's
It was
for
very, very long sentence, I guess.
Yeah,
but...
I just wanted to say that actually was an example how not to do it.
Yeah.
You should probably not show pictures and not talk so long.
But yeah.
I was looking, the network was going up and down, and I waited for it to stabilize. So now the next people should have a more comfortable way of talking. Okay, let's go with the people who have switched on. If you don't have a camera, but you still want to introduce yourself, you can raise your hand. And for me, the first is Patrick, and then is Nicholas. So here you go.
Okay, hello. Hello, everybody. So I'm Patrick. I'm actually from Italy, so I'm here as an extra today. Now, I use 3D printing for I work as an electrical and telecommunication engineer, and actually also use 3D printing for mechanical engineering. So in my case, I use it mostly for prototyping when you want to actually understand how big something is, or if it fits mechanically. It's very useful too, or also for prototyping parts. So making test assemblies that you just need to check if something fits. So both. So that would be on prototyping. On another side, I use it for clipping mechanisms sometimes. So you never know.
Things.
Yeah, because it's cheap to make plastic parts when you make several thousands. When you don't make several thousands, you can 3D print them, and plastics can solve a lot of issues. And
Great. Well, thank you.
Sometimes you can't do everything in metal.
Yeah. Let's continue with Nicholas.
All right, Nicholas. I'm originally from Italy, as somebody might know. I'm Patrick's brother. I'm living in Latvia, and I'm working for Antec and connection to 3D printing. Well, not much. I haven't done 3D printing yet, but made I've been doing 3D stuff for a long time now. So, and in my work, I occasionally do 3D visualization, but mainly I'm working doing some coding, doing some design, and doing some project management, IT field in general.
Your latest video was very awesome. You can plug it in the comments. Yeah, no problem. Okay, cheers. Thank you. The next one is Krish, and after Krish, we have Andra, and then if someone else will switch the camera on, we will ask also you. If not, then I will introduce Juris, and we will continue with the presentation. I'll talk.
Hello, everyone. My name is Krish, and I'm a product designer. I've been involved with 3D printing for quite some time now, and over the past few years, I have deeply fallen in love with hardware. And I'm still doing 3D printing every other day. So this is a very interesting field and competition for me. Thank you.
So very other day, I suppose, one day for modeling and one for printing.
Exactly.
Very good, very good. Oh, the printing also takes some time, so you can model light prints. Awesome, thanks. So Anders switched off the camera, I suppose. She doesn't want to introduce herself. It's fine. We already know everything, and I think let's go forward with Juris. I think we all know Juris is one of the mentors for this competition, but also as a 3D concrete printing pioneer in Latvia. So large round of applause from, I think it's still called Design Factory, but there are some name changes coming forward. But so welcome, Juris, and feel free to continue introduction yourself. I think each person knows themselves better.
Janis Miltiņš either raised the hand or is
I
clapping.
think he just clapped. He said
Okay, thanks for
because I said
clapping.
welcome with applauses,
Okay,
and he applauded.
Perfect. Thank you very much. So Yuri's microphone is yours.
Hi everyone.
No.
In last few minutes before this video meeting or learning, or how we can call it, Matis just said that, oh, everything will be in English. That's very nice. My English is not so good, so, but I'll try. And if I'm very make stress to your ears, then just switch me out from this. But my background is everything about. I hate digital world. I love real world, but I'm very long time, about 10 years in 3D printing, of course, in plastics, in hardware development, the printers, then how printers works, then how material works, then what's the best geometry, what the best how to use your brain and 3D printer and your geometry to get the best, fastest results. And I think we started a little earlier, check out what happens with the concrete or beton in Latvia, just to play around, to see what happens with the material, with the geometry before Mars. And of course, that was not so satisfying as plastic printing, because beton is evil, as we know. Yeah. Therefore, we must be in hurry before the beton is not
illegal. Yeah.
Yeah. But I hope there will be alternatives to make our bigger 3D world in real life. And therefore, I'm here to say how to show how make your small prototypes just for thinking, just for better understanding your projects, and how it makes how it can be realized at the best way in this competition. We are here not to judge you, but to help you how we can how we can make this a huge amount of beton to make something nice, not just a scratch that is there is a lot of scratching plastics, but imagine what happens if you fail in large-scale beton printing. Therefore, we can make a lot of pre-models to understand it's worth to waste a lot of beton or not. Yeah, that's it. Next, introducing.
Oh, no, we can continue with the talk. We finished all the introductions, and now we are continuing. You can show some examples, talk about maybe how to prepare the files better for the students. Or if you want, we can go through the works, but I already showed you, and students themselves know their works. I think we can go over the stuff that is similar for all teams when they prepare for print, like at least what file types to export or how they should send the files. I probably didn't announce yet to the students, but you will need to send in the files to Yuri's email, which is juris.kļava@gmail.com. I will send it in the chat later. You need to send the files till the 28th of December. So you have 1 week to send the 3D models. But remember, this is only the test print. So we are still in the first stage of the the second part of the competition. At the second stage, you will do the posters. At the third stage, you will try for those teams who need to do it a little bit of concrete printing. And at the fourth and fifth stage, you will 3D print the final scale model and print with normal printer the final poster design. But so far at this stage, you need to try at least if the scale works, and you can print the full model if you want, but assembly part is also very important, or you can just print a few details and try to put them together, see how it shrinks, how the material works, if the nozzle sizes are okay. So there are a lot of details. But I think we can continue with Juris, and yeah, if you have something to show, maybe some examples and all that, we can definitely go through. And afterwards, we will have questions. So if someone didn't understand something, if they have a specific need, then they will be able to give you a question.
Okay, me, yeah?
Yes, you're the main star.
Okay. Then I have a question because I don't know. I'm not very social person. Who is the most clever in what's the Maris hole is in the nozzle?
The sizes for that
Size
one.
of nozzle. What
the nozzle size. He did a presentation.
I think I will put it in chat. He sent us the presentation.
Yeah, we will put in the Zoom chat.
No. I want the number. Just number.
Yeah, we will find it and put it in. From the memory, no one remembers. But the thing is, he also has a variable set of diameters he can achieve. I think the smallest one was something maybe a centimeter. I don't remember.
Yeah, there was different nozzles. So I think you can also DIY the nozzles. Technically.
Yeah, he said he can also do custom ones.
But yes. The most popular ones we will write down in short seconds.
The ones he already tried.
Yeah, maybe someone from participants already remembers, but yeah, we forget.
So currently the models that students prepare, some use SketchUp, some use Rhino, some use, I think even ArchiCAD or Revit. So variety of softwares. I think Blender 3ds Max was also involved. So almost not each team, but almost each team has a different software in that regard. So for you, it would also be important in which file format you want to receive the models.
There is only two model files that is necessary for this competition, STL and OBJ. Only two file formats for slicing. Then why I'm asking what the hole size is. because here is two main things: nozzle diameter and layer height, and overhang, what holds the this when you're printing the concrete. And from that we can see how we can scale down your models, divide, see sometimes the worst thing is just the gaps, how it sticks together. Yeah, that is not understandable. There is zero, but in no mechanism there is zero gap. That is when you print a big number of parts, then you see that you cannot stick it together because the gaps is too small. You must see how it works. Therefore, I modified my 3D printer with the biggest nozzle size that is possible to 105 millimeter filament, plastic filament, and then we must scale down according to Maris nozzle diameter, and then scale down to 1.4.
So from his presentation, it's 20 to 30 millimeters diameter or larger. So yeah, he showed some examples he has already with 2 and 3 centimeters. Also,
so the 2 and 3 would be the most easy and common one.
Yeah, and then we, according to geometry or complexity of the model or the part of the model, we can decide what size of nozzle will be used, and then scale down, and then you'll see how big your small model will be, prototype of that, and then just print and make some better view of what will happen in concrete printing. Of course, plastic is more comfortable for printing. There is bigger overhangs. It cools down much faster than beton stays solid. But I hope that Mars will not allow his laboratory change with a lot of beton garbage and scratch. We will make some discussion about what to do or not what to do. But that is very, very, very good. We can see in small scale models, just to touch it, say, oh, it's very nice project, but you must redesign it because it's too nice to be printed. As I can show some samples from when we with my colleagues just have a brainstorm about some object, environmental objects.
yeah, different objects. Yeah,
different objects. What we can see in
outdoors. Yeah.
How in the world the pioneers of concrete printing doing, they just print like that. See?
Very good.
Very good. Yeah.
Then punch, put it on some surface and get some very nice idea. Of course, the combining of you can print. This is the 1 millimeter layer height. higher I cannot rise in plastic in my machines. Then you can play around with how it sticks together, or maybe in other shape, like here, here, and then play around. Sometimes for understanding, you don't need to print a whole model. You need just a fast proof of concept in some segment. And if you will wait for just to print out all the model, all big model, it will be very nice and happy. Then it's better to use your ammo to shoot a lot of times in some sector, not to make a whole model and then say, oh, I wasted a lot of time and material, but the result is not satisfying. Then my suggestion is think about what's the key point of your geometry, your project, and print maybe at, once, then this remodel a little again, and use your like not spend a lot of time on plastics and 100 euro, yes, is this amount of
Yeah, it's 100 euros per team for this stage.
To understand how it works, because if it not works, then Maris not will accept that it can be printed. Yeah, and of course, what's the overhang of your geometry?
20 degrees maximum.
20
degrees.
Yeah, it's like the slope can be 20 degrees, but the overhang, it's a bit tricky, I think.
And the other thing, layer height is 10 millimeters, so in scale to be 1 millimeter for the 20 to 30 millimeter nozzle.
Yeah. Then, yeah, then it's very necessary to. Sometimes you can somehow fool your overhangs just to splitting your model, turning, and thinking maybe you can reach some overhang that is much bigger and more nice, just to use your brain and split the model. And sometimes it gives very, very good and so magnificent results that sometimes things what 3D printer cannot do the best design, and it's based on technology what we using. Yeah, and yeah.
One question is, what's the most common mistakes when preparing files for 3D printing? Like when students send you files, what would be the most common mistake that could be made when exporting to STL?
Sometimes mistakes happens not because of the stupid student or experience, but just file is so, because the platforms what is the file is constructed is quite different, yes, from 3D Max. There is a lot of programs, but sometimes file is damaged, and there is bad to repair it. Yes, but sometimes yeah, that the file is not so bad constructed, but there is a lot of scratch.
Yeah, it could. The files maybe sometimes can be optimized, but I think the students still maybe send the files to you as fast as they can, and then you can take a look. Maybe we can suggest things that they can improve, and yeah, you never know.
Therefore, the date of 28th of December is so fast, because as fast as you can send the files to me, I'll say fast. It's shit or not shit. And yeah. And what else?
Patrick has some suggestions on the errors that can be avoided.
Yeah, I can suggest like two things mostly. One is valid, especially if you're using modeling software like 3ds Max or Blender, because so 3D printing, you can 3D print some geometry that has a closed volume, while in those softwares like Blender or 3ds Max, it's possible to make geometries with open surfaces. So you could remove one face, for instance, and at that point you have a thin surface. It's not an enclosed volume. In that case, you wouldn't be able to import the file. There's several ways to fix this, or also maybe you could generate geometry with intersecting with intersecting surfaces. So suppose like you have a sphere and a part of this face actually goes through a bit of the rest of the geometry. Therefore, in that case, the slicing software will have difficulties printing it. That's so just make sure in that case when you're making a file, to be printed, that it will work for the slicing software, that it has to be a closed volume, you know, a solid shape. Yeah. Quick look around for non-manifold models. Model mistakes is using the remesh modifier. Yeah, actually, that's true. There's another software also that helps you doing this. I think it's from Autodesk, maybe. It's called Mesh Mixer. It's a very good one to fix that kind of stuff usually. And yeah, another one is the actual printability. So you have to account for the fact that your model has to be printed from the bottom, I mean, in a certain direction. No, so you have to think about how, of course, the printer has to work. You know, one layer at a time. So I mean, and as you do that, also think about the fact that as you add layers one on top of the other, for instance, it will be difficult to print a column vertically, because as you print a column vertically, it will have a structural instability. So that's some of the things that you might have to think about. Okay, that's what I wanted to say.
One more very important thing is when you model your objects, then count on how thick the wall will be. Yeah, because if you sometimes make the model that you want to get, I'll show you somehow. For example, yes, here is 2, 1, 2, 1, 2. Here is 2 paths. Here is 1 path. And sometimes, if you know that the nozzle is 3 centimeters wide, then you cannot put on the printer something thinner than 6 centimeters. Yes, in the wall, because therefore it will not happen. Nothing. Therefore, is very important to think that in no one place the model must must be not thinner than 2 times of nozzle diameter. Yeah.
That's a good point. This like a golden rule of 3D printing.
There maybe is some things that can be done in slicer, just to put no infill, no bottom, no top, make extrusion smaller, the tool path is thinner, not so wide, but not everything can be done in slicer. Yeah. At first, I think, yes, as fast as you can, just send the files. Recommendation, just scale down to 30 to 30 centimeters. Yeah, 30, 30, 30. Just not to, if I put your model in full scale in my slicer, I just see nothing. There is a yellow big square. And then I must just imagine how big is the model. Therefore, scale down your model to 30 to 30 to 30 centimeters, and then I can check easily without problem.
Yeah, planned scale for final submissions is 110. I think for now we all can focus on printing everything in 1/10. If someone will have extremely large model, we can maybe go to 20th, but that will have issues with nozzle diameters. All that, I would say, if we can keep the 10th, that would be really great. Another thing, if you look at the Maris printer size, it's 1 meter in length and 26 centimeters, 800 meters in width, or 800 millimeters in width, and 400 millimeters in height. And in that capacity,
actually, I think height is Y, so
okay,
1
sorry, yeah.
meter 200, and the X was
Well, you
400
can always
millimeters.
rotate, yeah.
But yeah, like since the floor is big, you can always move the printer and make the, let's say, chair longer. But yeah, like Maris said, that the sizes are like
Yeah, I just wanted to
something
say,
around
if you
meter,
put
cubic
30
meter.
centimeter long part, there is a high chance that Maris will not be able to print a 3 meter long part. So you need to keep that in mind. But 1 meter is totally fine. I think you can go and risk a 2 meter part maybe, because he said that at least one dimension can be easily increased.
Yeah, you can always combine pieces together. Now we're just for this test print, you have to make just one piece. You don't have to make the whole
That is the
chair or
idea.
the thing. So yeah.
After the test print, Maris will check and look at these models, and then we will have a clearer picture when moving forward. Perfect. We have some more questions here. One of those you already answered. What's the print bed size? As I understand, your printer all models will be printed in Design Factory printer, I guess, or one for like Juris has access to. But the print bed there is 30 centimeters by 30.
Yeah.
35, 35 diameter I have, but I think for 100 euros you will ever
better smaller
size, yes.
So 30 is max.
The question
30,
here,
30, yeah.
actually, that's a very good question. I don't know if we can answer that, but for these 100 euros, what's the print volume or weight? What like parameter is easier to quantify, so they basically know that they are in budget? Do we, or if we don't have that, we can send it later to them, but it will probably be good to know how large volume they can roughly print. Of course, it depends on the surfaces
or you can show the examples, like how much, like how much is that, let's say, so the students can estimate what their models can cost.
In this case, because the nozzle size is very big, it wastes material fast. Yeah, this is about 4 hours printing, and the layer height is 1 millimeter is quite rubbish.
It's actually the same as we 1 millimeter is exactly.
And I think there will be some kind of symbiosis between material wasting and time of machine, because we just discuss it tomorrow, I think.
Okay, and then we can send them.
Yeah, but so it's like material plus the time. So at least yeah, the price kind of
we will give
together,
you like the max what you can. Well, of course, when you start sending in, he will answer you like, yeah, this is in budget, this is not in budget. But we will also give you tomorrow afternoon, I guess, then the dimensions and the rough estimate, so you can already plan ahead.
Yeah. Yeah.
I will check if there are more questions. Come on, okay. For STL and OBJ files, do you need both or only one of those is okay?
STL is better.
Okay, preferred.
If we move further after all these experiments, then it would be nice to have in some format where we can the basic file or step file or XT file. Sometimes it's faster to make some changes in the model by our side, not to teach you something strange or waiting for the result and 5 or 10 minutes just to improve some bad point in your model. Then I don't know what formats, because I'm working in SolidWorks. What SolidWorks understand that is very, very nice to make some changes fast and of course communicating with the author about changes. That is maybe one bad point can stop all the process, and it must be changed to move forward. Therefore, but that's after, because I cannot do nothing with the STL file. It's unworkable file for CAD programs. Only slicer there can be done some changes, but not a lot. Yeah. And what else? Yeah. Then I wait for the models in my email, and then after, if I see what's the matter, then I can comment and make it printable. As fast as you get the first samples, as fast you can understand what you have done.
The samples we leave at Design Factory. I suppose the samples we will leave at Design Factory or the guard that is at university. So we will just say you can come pick up, and then students can pick up them.
Yeah, somehow in that strange time, I don't know.
Yes.
I avoid to get some extra virus.
Yes.
Therefore, all the machines is in my home.
It's at your home. Okay. Then we can batch deliver them maybe after like a week or something, and then
I
put
think
them on.
also photo works at first. Like if the model is bad or good, we can send the photo to the student, and then they can think of improvements or something.
3D scanned model of the 3D print.
Yeah, I think it's the process is more important than the result.
Yeah. But yeah, it will be possible to pick up the parts too, just probably not instantly, but after a brief delay.
Maybe some participants have questions.
Yeah, that now is the time to ask them.
Or if Juris has also some other tips, but yeah, I think it's very important to ask those questions if you have them already about
Yeah,
your works.
don't hide them.
Yeah.
Ask, then I can think more productively.
Yeah, then we know where to focus.
What you
So-
don't understand or
Well, I think
have
there
problems.
already
then-
were a lot of questions, yes, but maybe there is
Yeah,
something
or
else.
also comments works and suggestions.
I'll give you 2 minutes to come up with a question. If you don't, we will stop. While these 2 minutes are going, I can quickly show. Oh, here we have the first model. Logistically, can the model be printed at home if we have access to a printer ourselves? Yes, you can. Only the problem is that the RTU budget or the virtual monies you have can only be spent on RTU printers. So that means that you will be funding your own research, which is really great for us. I suppose you can save that money for the next stage and do more prints in concrete or do more prints in paper. But otherwise, unfortunately, we cannot transfer this money outside of our RTU.
But
thing.
yeah, the people can try to print their own models and think about the layer heights and so on, and also update us if you're doing it at home, so we know how far
Yeah, you can
are
just drop
you.
in chat or send to the email, and we will just keep a tab. If you saw, that's what I wanted to show in these 2 minutes. Here on the shared Miro board, we already started updating the themes with these post-it notes, where you have this green note for the themes where Maris was able to give a consultation on the 3D concrete assembly. So that's all of the themes have passed that step. The next step was site selection workshop. Some of you still haven't gotten the approval from Latvian University. So for those of you, you need to send an email. I will put the email in chat with your chosen location so they can give an approval. When we have it, we will add the card to your team. So the teams that currently don't have approval yet, maybe I missed something, but that's how, at least on our side, what we see is B98 question form, habitat, and crazy idea. You don't need to be super stressed, but it's definitely a thing that you need to at some point get this feedback from. And for this part where we do the 3D printing, like at the end of this section, we will also add a checkbox for the teams that have gotten like done this test print. And that's how you collect these checkboxes, and at some point be ready for the final presentations. The next one, I think in 28th of December, it's just the deadline to send in the models. Juris will need some time to get through them. So the next meetup will be after that, but then we will announce it in chat and talk with him which dates work for him. And maybe also ask Maris to join then, and we can go through the results together. So basically you have 1 week now, and after that deadline, we will contact you if you need to send in more precise model prints. So for another week, and then we will have a results gathering. But this 28th of December is quite important, so mark it in your calendars. By then we need to have that print, because printing also takes time, and it's not that Juris has infinite printers. He would like to have, I suppose, but there are always limitations in the real world, and material is one of the limitations, but time is also a limitation. So that's another reason why the deadline is short, because we also need to have a time for printing. So that's like that. Do we have any more questions? I see that there are 2 questions. Awesome. So if we print ourselves, we don't have to send it anything for 28th of December. You need to send a picture. No, I would say you can still send them. Well, you still need to show us that you are doing something preferably. I would say send the model, but you can write that you don't need it printed. You just sent it in for comments. Maybe Juris can give you a suggestion how to slice it better or something like that.
Yeah. Then you can send to yourself and send to my email just twice.
When you send the models, add our competition email too, because then we can
as
see
CC,
that.
so we can see that that would be the best, so we can see
Otherwise,
that
yes,
you have done
we don't
this.
need to. We know that we don't need to trouble you and
Yeah,
remind you.
perfect. And the question from Jānis Miltiņš, can you recommend a good beginner 3D printer to start with for plastic printing? Maybe
Oh, that's a good question.
maybe Juris has suggestions for beginner 3D printers.
Yeah, probably Patrick
Oh,
also has.
I don't know the experience of your 3D printing, and of course the cheap ones is you must be clever. As less money you spend on 3D printer, as much you must be high experienced in 3D printing. What happens there? I don't know. Maybe Krish can suggest. It's a combination between hardware, material, and software where you slice it. Therefore, but you must practice, and then you see what is in the market. In what sometimes someone buys a 3D printer, maybe not so cheap, but there is not good results, and it sells it for the cheap money.
For a good 3D printer for starters, if you have the budget, then probably a Prusa printer, because it's fairly reliable. But if your budget is not that big, which is understandable, then I would suggest probably from Creality 3D printers. However, I would suggest adding a bit of money and buying, instead of Ender 3, to buy the Ender 5 3D printer, because that one has it's better, it's more well built in comparison to the Ender 3, and it also requires less assembly, because for example, I like printing and I like the things I can create printers, but I hate fixing the printer. So yes, those are my suggestions on top of my head. However, if you decide to go, if you know that you're not so much into functional parts, but you're more about visuals and small detailed prototypes, then I would suggest SLA printers either from Elegoo or from Anycubic. They're basically the same, and you can get them very cheap. So yeah.
Yes, thank you, Krish. And Patrick, you can also share your comments, because you shared them in chat, but so the everyone else watching the live stream can also hear your comments. Yeah.
Here we are. In truth, I've been using mostly. I've been using two different printers, so not that many to have an actual experience. Which was an Ultimaker, and the other one is Prusa MK2. And I have to say that with the Prusa, we have actually two at the company right now, at our company of Prusas. And with the Prusas, I've never ever had to I've never had problems. Basically, every print was always very nice, always perfect. It actually helps you build it, and it's very reliable, simply put. So if you use a printer for work, but you don't really need to print something every day. Like in my case, I'm doing mostly prototypes to check if parts fit correctly. If some parts are actually functional. In that case, it's without having to send stuff at manufacturers, and having delays and all of that. In that case, a 700 budget becomes immediately, justifiable. I know they also have a smaller version, which is around 300-400, and from what I've been told, it's as reliable. So maybe that one could be interesting for a beginner. Otherwise, yeah, that's my experience with them.
Thank you very much. And yeah, you also wrote down that they're like starting from 400, which sounds very reasonable.
If you can spend about the MK3, I think. Let me check which one I'm using.
Yeah, definitely. Yeah, just write down. We'll try to kind of compile all these nice comments. And Vladimir Anderson's had questions, so we can switch to Vladimir's.
That's a very good question. I will read his. He's very good. Yeah,
Hello, everybody. Yeah, Juris Kļava changed my mind a little bit about slicing, because before I don't know that. If I understand right now, we can change the height of the layer when we are printing as well. And I want to ask where we can change this height of the level, like it is doing the slicer program, and which the slicer program would be more suitable for this, because right now I'm using a repeater host and it's enough for me, but there I wasn't changed the layer height, so I'm not sure that I can do that there. So my question is, maybe you can get suggestion which would be the slicer the best, and yes, that would be the question.
What you want to do with the slicer?
Exactly.
In slicer, you can slice your object in like sheets of smaller, bigger. Sometimes it just suggests, oh, your nozzle is too small for the size of layer, or something like that. I think the best, because we are not printing or playing with the plastics, we are trying to build the most printable objects in concrete. Therefore, the slicing let in our side. You can play with in repetier. There is a lot of options that you can do with your layer, and sometimes there's toolpaths, some beautiful changes. My favorite is Simplify slicer. There is a lot of good things inside. Everything I want, I can do with this software according to the printing model.
Yes, Juris, I'm sorry. Maybe I'm not create my question clear. The question was, can I change the layer height in the slicer program, or in which program I should to do it? Because right now, like printer, when it is printing, he's printing layers, and the layer's height is not the same as the width of the layer. For example, I have nozzle like 2 millimeters and layer as well, not 2 millimeters high. And the question is where I can change this layer height. It's doing in the slicer program, or it is doing in somewhere else?
Of course, only in slicer you can change the layer height. Yes, and therefore, because the properties of the layer, yes, that's not the layer height is not more than 1/2 of the nozzle diameter. Yeah, it's like a basics. Sometimes if you want to make some experiments, then you can avoid such rules. Yes, but as sometimes you can get sharper overhangs if your layer height is not so big. Yes, then you can reach an angle that is bigger than 45, or sometimes in concrete printing also you can get bigger overhangs or sharper, or not sharper, but what's the word? Izteiktāks.
More precise, I guess, or
Oversized
articulate.
overhangs if you decrease the layer height. Yes, because there is not so big material mass that can be just drop down because of gravity.
Mhm.
Yeah, but yeah, in our case, we will try to make your scaled model in the same size of layers that will be in the concrete printing, with 0.4 nozzle, that is standard nozzle for beginner printers. Yes, and there will be too smooth for understanding what will happen in concrete printing. Therefore, I have a biggest nozzle for standard filament that can be melted, and therefore you can see how it will be with the big layers, with not smooth surface. What happens with big nozzle only in scaled model. Yeah, it's maybe it's good point how to start 3D printing, but in this competition, I think it's better to polish your idea model, not to start learning printing. Sometimes it just stops that when you ask yourself, you want to fix your printer or you want to print. In Design Factory also, there is a lot of printers. You can somehow go inside and print your models and play around. But of course, if we want to check out your models and your brains, and according to our possibilities to print out your model in concrete, then yeah, I think we need to print ourselves or spend that 100 euros by our side to check if is it worth to do or not, or what improvements we must do. Yeah. Yeah, but the first point is just to start with your models to understand how we can split it. Of course, the whole model I not suggest to print because it's scaled Maris printer. Split in scaled how it will be splitted in, like according to Maris size. And because this splitting is sometimes it's very nice, but sometimes it's also very how the parts is stick together. It's very important how it happens. If it's too complex, of course, then problem.
Yes, thank you, Juris Kļava. And now I understand that if I want to make my model more realistic, more that it will looks like on 3D concrete printed, so I need to think about the speed as well. Yes, like because I don't know how you will print. Maybe because right now, no, I have a working printer and he's working very fast. Like nozzle is coming very fast, turn back, turn left, and I understand like the speed of the nozzle is has impact to the model, yes, to look more realistic, that it's printed like concrete.
No, I think there is
more
more heavy point is the melting speed of the material. Yes, if you have a big nozzle, yeah, the melting speed must be huge. Yes, if you drill just with a 1.5 drill in your Prusa printer, the hole bigger. Yes, just forget to print it fast because it will not melt so fast as you want, and not cool down as fast as you want, because there is a lot of heated material. It's not just with a small nozzle, with a small layer, you can print very fast because the amount of material and heated material is so small that it's you can print and see how good the layer adhesion between the previous layer is. If you print too fast, it just not sticks to previous layer so good. Yeah, but yeah, with the big nozzle, you need to print as fast as your heat block of your hot end can melt the material. Yeah.
Thank you. Maybe someone else wants to comment on this, or we move to another question.
Patrick wrote a very good answer, but I think you can just read it. Yeah, I think, yeah, if you have any else questions, I can say about the previous question about the printers. We use the in-cast print Ultimakers. I think we have 8 currently. For production, they are quite good. At least they were good. There has been some time I haven't visited the office, but they did cost a bit. The new ones especially are getting extremely expensive. At first, they were not that expensive. I think we spent maybe 1,000 for one. Now they are like 5,000 for one. But what is nice, you can print like in 2 materials and then dissolve one and something like that. But maybe there are people who have tried the newer versions. I don't know about that. Another thing is you can always try a resin printer. They are a bit more messy, but resin printers give you more layer detail. And there are some more benefits, but they are messy and you do have to clean them, and that sucks. We also got one resin printer, and it's a work. It's not that enjoyable. Yeah.
But sometimes there happens a good number of art when because of fails, like
Wow, so
that
good.
is not the model that
Yeah.
was in Slicer, yes, but
I think
Very
that's how you create
artistic.
art. That's how you create art.
Sometimes mistakes are great.
sometimes it's like a spa
Yeah.
because of gravity. Yeah,
Yeah.
What material is this? The layer height looks like 5
Very big.
millimeters or a centimeter. Is it concrete?
this is like
Plastics? Maybe it's in Latvian, you can tell it.
Yeah, it's fine.
this concrete from lightweight concrete.
Oh, lightweight concrete. Okay.
Yeah.
Erwin's likes that concrete a lot.
Yeah. Okay.
This is heavyweight concrete. Yeah. You see what?
Is it printed with Maris printer or different printer?
No, it's
No.
not
It's
from
2 years
RTU.
earlier than
okay.
Mars.
He didn't have yet
Yeah.
built the printer. I think it's only 1 year.
OG concrete printer. Yeah.
Yeah.
That there is a lot of problems in beton printing.
Oh yes.
Yeah, actually, I just wanted to add that Maris Schinka from RTU 3D Concrete Printing Laboratory, he had his presentation on 26th of October. So if you're more interested in 3D printing or you want to refresh your memory, you can still watch the video on Creative Tuesdays page. And he had a quite long presentation and also showed the height, the dimensions, and also, yeah, these mistakes, like if you go too fast, it will just like rip apart, or if you go too slow, it might rip apart. And also, yeah, it can kind of slide because of the gravity. So it's, yeah, you can think about it while watching the video there. And yeah, so but about the plastic printer, yeah, Juris will be able to answer to your questions if you send him email or now.
Perfect. I think thanks to everyone who joined. If we have some closing questions, then can do it. But the official part is off. Or we will stop the live stream and then have an after party or like get to modeling. The deadline countdown has started.
1 week. For your quick
yes.
models.
Merry Christmas. Merry Christmas.
Yeah.
May it be productive for you. Yes. You can now give a gift to Juris the model.
Yeah.
Also, if your model changes later, that's totally okay. It's not that you are locking it right now, but at least you have tried and you understand how sending files work and which stuff works, which doesn't. So if you still want to adjust some design parts later up to the third stage, which is concrete test, you can do that. After the third, you go for the final. Perfect. See you all some other day and some other Tuesday. And for now, good luck. One nozzle prints support and the other nozzle.
Yeah, in truth, it would make sense to have some, grid-like support material, which might be flexible, but might be, somehow semi-permeable, and that could go through with the concrete, and in order to add some manufacturability to the system, because I mean I wouldn't expect a lot of added resistance apart from tensile apart for something like tensile stress, unless you add also pillars or somehow, but yeah, it would help a lot, especially on the structure, not to have a soup that would go around the walls. But I don't know, I mean, in truth, I haven't thought a lot about concrete printing, so but it would make sense though.
We need to rent a big pool and bring down the water. Then the gravity is not so making so bad.
So heavy, or
Yes.
Okay, in order to compensate for the weight, you mean? But I mean that's difficult in the case you want to make big parts like buildings. I don't know. In truth, I don't know. But I mean, I can imagine strings are going through the nozzles, somehow. Somebody will have to build a machine like that sooner or later.
Yeah, Erwin's also made a good point about eco resins, I guess. If you want to, you can jump in, Erwin's. Yeah. Basically, he said that you can use these eco materials. They don't smell so much. Only kind of flaw is that they might turn yellow. So it's only for prototyping, not maybe for the real kind of products. And yeah, maybe if someone was shy to ask questions in the live stream, you can now do it. We have some few minutes left. Otherwise, yeah, just get ready for email. We will send you the details where to send your first model.
Because it's better understanding is through the work.
Yeah,
the model.
just by doing, yeah.
And then there's a lot of thoughts and less words, and sometimes therefore I just suggest to print as fast as you can something don't understandable for you, because you cannot touch it and see it. And the first prototype must be for angliski apdiršana.
Not sure.
Failure.
Yeah, the first model is for the
shitty prototypes.
Shitty prototypes, I think.
Criticize.
Yeah, just to
understand what's bad.
Yeah, for all checking all the problems, flaws, and basically see where it kind of doesn't work. So yeah. the first model should be like bad. Actually, like it has to be fast, just to create something, show it to us, and then if you have this model, then we can work on it and improve it.
In my mentor experience, there is a better results for those who just passed as many mistakes.
Yeah, like
The
quantity.
final job,
Yeah.
and sometimes they have better results in the final than instead of
Yeah.
those who just
Have
make
only one.
perfect and perfect sheet, and it means nothing, just
Mhm.
and then
Yeah.
and that I'm not genius. No.
So quantity is good for 3D printing, I guess. So
Yeah,
more.
sometimes
The
quantity
small
leads to
parts.
quality.
Yeah. More
Iterations being the
iterations,
key word.
exactly.
Yeah.
Okay,
Thank
Those
you,
Patrick.
Juris,
small parts
for
help a lot, for sure.
Yeah.
And actually, another thing that helps is, just taking templates from, printer manufacturer. I mean, 3D printers manufacturers. Sometimes they give you templates to try. Those help, getting the hang of how the thing actually works. But, yeah.
Great.
Great.
Well, thanks to all who participated, especially
and-
Juris, Patrick, and Nicholas also. After
And
offline.
Chris,
All cheers, yeah. See you all.
thank you. Bye bye.